Okay, question 11. A uniform rod, AB, has length 3 meters and mass 24 kilograms. A particle of mass m kilograms is attached to the rod at A. The rod is balanced in equilibrium on a support at C, which is 0.8 meters from A. So we got a diagram of our rod. We want to find the value of m. So, first of all, if the rod is in equilibrium, we know the moment about C is 0. The rod isn't rotating at all. So, the formula for a moment is the distance from the pivot times the force. So, let's think about the forces. At A, there is a downward force of m times g. At the pivot itself, we have the normal reaction force acting upwards, and the rod has a mass of 24 kilograms. Now that's going to be working downwards at the centre of the rod. So that's going to be 1.5 meters along. So that is 0.7 meters from the pivot, and it's going to be 1.5 meters from point B, but we're not really worried about that. So the force here at this point is 24 times gravity. So the moment about C then is, well, at A, this is trying to push the rod anti-clockwise, so that is a positive moment, if you like. So that's going to be m times g times 0.8. So there we got 0.8 mg. Now, over on the right, this is trying to push the rod clockwise. So this is going to give us a negative moment. So this is going to be 24g times 0.7, but negative. So we got minus 0.7 times 24g. Now we know that that is all equal to 0, because there is 0 moment about C. So there is a common factor of gravity, so we can divide that away. So we're going to get 0.8 m is equal to, so we're also going to add this other term to the other side, is equal to 0.7 times 24. So M is 0.7 times 24 over 0.8. And that gives us 21 kilograms. Go.